Hello everyone, this is Billy D here with a short video in regards to an NSM project I've just begun. So let's get started. Here's a rundown of what I'll be going over in this video. First, why I believe these videos and NSM are a subject that's important. Next, a little bit about me, and then my current NSM setup, how I'm actually pulling this data, and then finally the project I'm working through. So why am I posting this video? First is to share information. There's a lot of resources in open source that I am using, so any contribution that I can help out with, I would like to start doing so. And then second is to document this network analysis that I'm working on right now. So about me. I've been working in network management for 2 years, working on equipment like Cisco, Juniper, and Brocade over satellite, fiber, and Ethernet backbones. Before that, I worked in the satellite transmission field, working on FDMA, TDMA, and other variations of shared satellite bandwidth. When setting up a network security monitoring system, there's a lot of things that go into it, and so many hours that I can't even count, going into hardware and cabling and virtualization and all of those things. But the gist of it is that I've installed Security Onion instance on an ESXi host, and then from an Ethernet switch, I've spanned all of my network traffic to the network card on the Security Onion VM. So it's getting a complete representation of all my home network traffic. Besides the basic Security Onion setup, I installed Splunk Enterprise as a log server, and there's lots of write-ups online to walk people through that, so I'm not going to get into that, except for Splunk is a very powerful tool, and it's helped me out a lot. So on to the meat and potatoes. First, I do most of my monitoring from the Splunk Security Onion dashboard, and get in there. If something looks interesting, then I'll look at some dates and just some log files from there, but then I'll pivot to Snorby to dig deeper into the subject. From Snorby you can look at destination IPs, you can look up where those destination IPs are registered to, and then you can pull a PCAP off of those files, and from there you can pivot to Wireshark to do a deeper analysis into the packets that are going back and forth. And in this case, it's an image that's getting posted to a web page. So from Wireshark, you can actually pull out that image that is getting posted to the web page, and see what's getting pushed across your network. And then in the future, hope to get a better knowledge of process inspection and host-based intrusion systems, so that you can see what's actually going on in the host to stop this type of activity. Alright, now we're in the Splunk console. So I want to get back to the main console. This is Splunk, where you can do all your searching. Within here you've got the Security Onion dashboard. It's where I'm going to look within the 7-day span, and you can see that right here is the activity that I'm looking for. Trojan activity, 16 counts with less than 1% of my network alerts being those alerts. So I want to dig deeper into this. Down here in the bottom, it's looking for that data. You can see that my host 5100 is looking at 107, and it's that Trojan alert. So I want to get a better representation of that. You can see that I've got 16 events where this is logged, and it's all the way from January 30th to January 25th, and when we dig deeper, we'll see that there's more than that. But from Splunk, you can get the gist of the story. Date, time, group, the PID of the signature, the type of signature that's being alerted, the monitor, the network card on the Security Onion instance, the name of the alert that's being alerted. You can see that it's a post to an image file, GIF. And got my host, distant end host, and source port, destination port. And between those two dates, now I want to go into Snorby. Snorby's an NSM console, so it's made for this. So I'm going to search for the signature that we just found, which is ET policy data. Post the GIF. Find all the alerts, Security Onion, and we can see that there are multiple addresses that my client is posting to: 107.20, 23, 21, and 54.225. So who are these guys? Who are these IP addresses registered to? That's what I want to know first. So basic lookup, and 107, this IP address is registered to Amazon EC2, which is a part of the Amazon Web Services suite, and so it's registered to a virtual machine in the cloud that is purchasing services from Amazon. So if we go into the other one just to verify, see if this is all the same type of info. This is Amazon also. Different organizations within Amazon, but all in their cloud. And 54.225 is the same. Amazon 2011 L, all within there. Alright, so we know as much as we know about who it's coming from. We've got a date time frame all the way from January 14th to January 30th. We've got the policy, and now I want to look at this within Wireshark so I can pull the packet capture, and just want to remember this port 2562. Everything within an hour time frame of 2562. 80 is the destination port, and then we want to pull this PCAP file. See, here's what it came back with after I submitted that request, and then I can pull down this PCAP file, open it up with Wireshark, and now we can start looking at the packets that happened. It's the context of the situation. So we saw the alerts, but there was traffic going back and forth before the alerts. So we've got the full context of the TCP connection. First three packets, setting up the TCP three-way handshake. You can see here that it's doing a post to the web page, and it's doing a verification of the post. It's doing another post. It's doing a verification of that post, and then it's tearing down the TCP connection right here. So we just saw all that traffic. Now you can drill down into this window here, and you can see more information about, like, the Ethernet ports. This is on my side of the network. I've got a Cisco switch that's pulling it through there. But now let's look at this in a TCP stream. More chronologically what's happening, easier for the human eye. So you can see a URL. Let's go into, does that DNS resolution. You can see that there is an encoding, could be normal, could be abnormal, and for the actual data that's being posted, the confirmation from the web server, and then it does it again. Confirmation. And that's that information. Now we want to export what it's calling a GIF and pull that up in Paint and see what that GIF looks like. See this little icon up here, and we'll zoom in as much as it'll allow us. And what we're going to find out is that it is nothing. It is a blank picture, blank white document that's being posted. So why would that something blank white be posted to a web server automatically from one of my hosts? I mean, I'm new at this, so it could be because there's something going on that's allowing it, and it's supposed to be that way. But it could also be that there's a malware, virus, or botnet on my computer that's doing the post for me. And within this document, within this white GIF, could be encoded information that would tell the web server information that it's pulling from my network or from my computer, you know, whatever information that it's trying to receive. Or it could just be a simple hello, you know, I'm here, ready to work when you want me to, type of information. But that's as far as I've gotten. Next is getting into the processes and seeing, you know, what actually might be happening on the network. To allow this type of thing, and dig deeper into this. This has been had Security Onion spun up on ESXi for a couple of years, and there's been a lot of false positives, stuff that I've thought was going to be an infection, but it was not. And this is the first one that, you know, I have not been able to rule out in a day that it is not an infection. So I'm going to keep on digging deeper and figure out, you know, what's causing it and how it's doing it. So that's it. In conclusion, home and work networks are constantly being attacked. So what are we doing to stop it? For the teams at Security Onion, Ubuntu, Kubuntu, and Snorby, you are awesome. Splunk, you're awesome too, but you get paid to be that way. I hope the information has been informative, and thank you for watching.